Okay, moving on. What we're talking about, chapter 2, at least some of what we're talking about, has to do with measures of central tendency. There's three main types. Well, very often we'll hear people say, well, they took an average of something. Well, that can mean some different things. There's three different types of a measure of central tendency. The purpose of using a measure of central tendency is to provide the best description of a group or set of data. That doesn't necessarily mean that we always have to use what we're familiar with as a mean. And the mean, as you know, is where you add up all the numbers, you divide by how many you have, and you come up with a score. So, for example, in the job involvement scale, you had numbers of 1, 2, 3, 4, 5. You added those together, and then you divided by 12, and you came up with a score. That is one way to do it. However, as we've seen, that's not always the best way to do it. And sometimes it's an inappropriate way to do it. Another type of measure of central tendency is something called the median. The median is the number that's in the middle. So if you rank all the numbers from top to bottom, it's the one that's in the middle. And finally, the mode is the one that occurs most frequently. And as we saw in the example, the job involvement scale, that sometimes really is the best way to provide the overall best description of a set of data. So if somebody tells you they got an average, the average score for a set of data was 88, that could mean a lot of different things. It could mean one of these three things. So let's look at an example. Here we have the salaries of district administrators from a school district, ranging from 199,000 down to 76,465. Very often somebody might say, well, what's the average district administrator salary? And we can do that with this. If we do that, that means that the average district administrator salary is $94,962. Because what we do is we add those up and we divide by 11 and we come up with that number. Most of those people are going to be upset with that. I have 10 on there. That's not actually right. It's probably 9 are going to be upset because they don't make that much. That does not represent how much most of those people make. And in fact, it doesn't represent how much any of them make. There's 2 that make more than that, 9 who make less than that. Nobody makes that much. So it doesn't really represent the average salary of the district administrators. And there's one other thing that we're going to get to in a minute when we talk about skewness that's throwing this off. And hopefully you'll be able to see that. The median and the mode, these numbers, probably are a better representation of the data. The median, which is 87,245, and the mode, which is 87,678, are probably more typical of the average administrator salary. All of this depends on something called normal distribution, but sometimes things are not normal. Sometimes the data is skewed, and hopefully most of y'all are familiar with something called the normal curve. We're going to pause for just a second. This is data or a document that's available in your modules. I'll blow it up and look at it. This is a normal curve. We've seen this before. It's also known as a bell curve, also known as a Gaussian curve. Gauss is the person who came up with this. And basically what this means is that for any group of data that's normally distributed, some of it is above the mean, some of it is below the mean. And it's also divided into these brackets. So going back to this, we would like to see things be normal. For example, IQ scores fall in a normal distribution. 100 is an average IQ score. Of all the people in the world at which IQ tests have been taken, we have figured out that the average is 100. That means that half of the people in the world have a normal distribution greater than 100, or a score greater than 100, and half of them have a score less than 100. But sometimes when we have smaller sets of data, like this, things aren't normal anymore. Sometimes we can have one positive number that is pulling up the average, and it throws off our standard deviation. Our administrator salaries here are a prime example of that. We have one person who's making nearly $200,000 a year. That one score is providing a positive skew for the rest of the data. The same thing can happen on the bottom end. Let's say that there's one person who had a very, very low score, but everybody else is pretty well grouped together. That means it has a negative skew. So there's two different ways that we can look at that. All statistics, all inferential statistics are based upon using normal curves, and when things are not normal, we can't use them anymore. Another way in which data gets misused or is misrepresented is the how it's distributed. So for example, we can still have a nice bell-shaped curve. This is called a mesocurtic curve. You don't have to know what these terms are. This is just about looking at data. Sometimes there is a lot of data that's right in the middle. So for example, going back to our administrator scores, if of those 10 people, 9 of them made $95,000, they all had the same salary, then all those scores would be lumped right in the center. If on the other hand, that's called leptokurtic, if on the other hand we had 2 people making $45,000, 2 people making $55,000, 2 people making $65,000, 2 people $75,000, etc., etc., we have the same number of people in each part of the distribution, we get what's called a platykurtic curve. Now, so if things are not distributed normally, this curve won't look the same way anymore. It can be pulled one direction or the other. It can be flattened out through the middle. It can be raised up in the middle and pushed in on the ends. If that's happening, the data is not normally distributed. If the data is not normally distributed, then it becomes increasingly difficult to use any kind of statistics to make a data interpretation. The point all this is very often we'll see people using statistical analysis on data that is not normally distributed, or data that is not really interval or ratio data, that is some other kind of data, and they're applying a different kind of statistical test for it. Next video, we're going to talk about standard deviation.